Okay, so I thought we'd take law of cosines and we would use that to approximate the diagonals of a parallelogram. So here's this parallelogram here. Um, so it has side 30 here, so this side must be 30 here, side 70 here, so this must be 70. So this is what I'm going to try to do. I'm going to look at these diagonals one at a time, I think. So this is what I'm looking at. This is how I'm trying to envision this myself. I'm looking at this as two different triangles now. And the first triangle I see is this one right here. That goes with that, so hopefully you can see this triangle. Maybe I picked a crappy color. Anyway, this is the triangle I'm looking at right now. Some stuff that I know automatically is this. I know that if I take a parallelogram and I cut it with its diagonal, this angle and this angle have got to be the same angle. So this is also 65 degrees. So this is what I think I'm going to do. I'm going to say that side AC, because this is the diagonal I'm looking at right this second. Let's look at this diagonal here in red. So I'm looking for this diagonal right here. So I'm just going to say some stuff about it. And some of the stuff I'm going to say about it is that AC squared is equal to, this is my law of cosines, isn't it? It's equal to, right, it's equal to 30 squared plus 70 squared minus 2 times 30 times, 30 times 70 times cosine 65 degrees. Here's the triangle I'm looking at right here. This is my triangle right here. Can you see it? This is the triangle I'm looking at right now. So this is my law of cosines. So I'm going to just do some math here, and I'm going to say that AC squared is equal to 900 plus 4,900 minus, what is that? What is that number? Oh, you know what? I'm going to go ahead and do this as this whole mess, including the cosine of 65 degrees. So using a calculator, I'm going to get minus 1,775 as my total number here, right? So that gives us this, that AC is equal to the square root of all this crap, and all this stuff put together comes out to be 4,025 degrees. This is Charlie using a calculator, and it's the square root of that mess, which comes out to be 63. So there's that. So we have this value here is 63. So that's one. Now we have to look at this other diagonal, and the other diagonal we want is this one, right? It's this one right here. Right now we're looking at this as it was this triangle. But remember, what we're looking for is this diagonal right here. And what I'm going to do is this. Look, there's lots of ways to do this, and I had an argument with somebody about this morning. How can you prove this? And this guy says, oh, well, consecutive angles are supplemental, which means this has to be 180 minus 65 is equal to 115 degrees. I totally agree. 115 degrees. I also know this, that if we have 300, the interior angles of a quadrilateral have to be 360, right? So we have 360 degrees minus, right, minus 60, right, minus 65 plus 65 minus 65 plus 65 divided by 2 is equal to 230 divided by 2 equals 115 degrees. How did I get that? I'm not saying this is the way. I'm saying this is a way. There's tons of ways to do this. This 65 and this 65 have to be the same. These two are also the same angle. So we've already accounted for 130 degrees of our 360, which leaves us 230 degrees left. So took that, divided it by 2. So this is also 115 degrees. So now we're going to work on that other diagonal, and it's, look at this for a second, really quick. It's length BD. So now I'm going to take that and I'm going to say BD squared, right? So BD squared. So BD squared, this again is me applying law of cosines. So BD squared is equal to 30 squared plus 70 squared minus 2 times 30 times 70. See a thing here? Cosine of what? Cosine of 115 degrees, right? What are we doing? We're taking side angle side, right? So side angle side, okay? So side angle side, or yeah, let's do side angle side that way. All right. So that's where I'm getting all that mess. And when we do this bit out, this comes out to be BD. And I'm going to skip all the extraneous arithmetic that I did before, is the square root of 7,575. And that's equal to about 87. So this diagonal here is, the yellow one is 87. All right? So I hope this was helpful, just the application of law of cosines. And remember, you got to memorize this law. So good work. If you haven't already subscribed, please do. And your comments, of course, are always welcome.